Designing the enterprise. 1. Using WAN technologies. Numerous WAN technologies exist today, and new technologies are constantly emerging. The most appropriate WAN selection usually results in a high efficiency and leads to customer satisfaction. The network designer must be aware of all the possible WAN design choices while taking into account customer requirements. This section describes the use of various WAN technologies, including remote access, VPNs, WAN backup, and the internet as a backup WAN. Let's start with the traditional WAN technologies. So traditional WAN technologies includes the following. You've got the list lines, point-to-point connections indefinitely reserved for transmissions rather than used only when transmission is required. So you also have the circuit switched networks, a type of network that for the duration of the connection obtains or dedicates a physical path for a single connection between two network endpoints. And you've got the packet switched and cell switched networks. A carrier creates permanent virtual circuits or PVCs or switched virtual circuits or SVCs that delivers packets of data among customer sites. Now for the WAN topologies, we have this star or also known as the hub and spoke topology. So the benefits, network simplicity, low number of circuits. The only drawback is suboptimal traffic flow. There is no redundancy here. So if the hub goes down, well, all the spokes are disconnected. The next topology is a full mesh topology. So benefits, any-to-any connectivity, high level of redundancy. Drawbacks, configuration complexity, and of course the number of circuits. And you also have the partially meshed topology, a compromise between the star and a fully meshed. Designing the remote access network. So the objective is to provide a unified solution for remote access. Grant the connection seamlessly as if in the company headquarters. Application requirements includes low to medium volume data file transfer and interactive traffic for teleworkers and traveling workers. Voice services for teleworkers. Connectivity options, IP access through an on-demand or always-on connection. So technologies includes dial-up, the old dial-up, DSL, cable, wireless, broadband, and others. Overview of a virtual private networks or VPN. So a VPN is a connectivity deployed on a shared infrastructure with the same policies, security, and performance as a private network, but typically with lower total cost of ownership. And we are using the public network like the internet to provide connectivity among sites. So connectivity option, first is the overlay VPN. So VPN connectivity options like the overlay, VPDN or the virtual private dial-up networks, and peer-to-peer VPNs. Now let's focus on the overlay VPN here. With overlay VPNs, the provider's infrastructure provides virtual point-to-point links between customer sites. Overlay VPNs are implemented with a number of technologies, including the traditional layer 1 and layer 2 technologies. Okay, so overlaid with modern layer 3 IP-based solutions such as the generic routing encapsulation, GRE, and IPsec. So you can check the supplementary videos to learn more about VPNs, GRE, and IPsec. So from the layer 3 perspective, the provider network is invisible. The customer routers are linked with emulated point-to-point links. So the routing protocol runs directly between routers that establish routing adjacencies in exchange routing information. So the provider is not aware of customer routing and does not have any information about customer routes. So the provider's only responsibility is the point-to-point data transport between the customer sites. So although they are well known and easy to implement, overlay VPNs are more difficult to operate and have higher maintenance costs for the following reasons. First, every individual virtual circuit must be provisioned. Optimum routing between customer sites requires a full mesh of virtual circuits between sites. Bandwidth must be provisioned on a site-to-site basis. So this figure here illustrates an overlay VPN. The router on the left in the Enterprise Edge module has one physical connection to the service provider with two virtual circuits provisioned. You've got the virtual circuit 1 and then the virtual circuit 2 here. Now VC1 provides connectivity to the router on the top right. Okay? Whereas VC2 or the virtual circuit 2 here provides connectivity to the branch office router to the bottom right. Next would be the virtual private dial-up network or the VPDNs. VPDNs enable an enterprise to configure secure networks that rely on an ISP for connectivity. With VPDNs, the customers use a provider's dial-in or other type of connectivity infrastructure for their private connections. A VPDN can be used with any available access technology. Ubiquity is important, meaning that VPDNs should work with any technology, including modem, ISDN, XDSL, or cable connections. So the ISP agrees to forward the company's traffic from the ISP's POP to a company-run home gateway. So network configuration and security remain in the client's control. So the service providers or SP supplies a virtual tunnel between the company's sites using a layer 2 forwarding or point-to-point tunneling or IETF layer 2 tunneling protocol L2TP tunnels. Now this figure here illustrates a VPDN. In this figure, the ISP terminates the dial-up connection at the L2TP access concentrator or the LAC and forwards the traffic through dynamically established tunnels to a remote access server called L2TP network server or the LNS. All right. Now, a VPDN provides potential operations and infrastructure costs or cost savings because a company can outsource its dial-up equipment, thereby avoiding the cost of being in the remote access server business. So the next one would be the peer-to-peer VPN. In a peer-to-peer VPN, the provider actively participates in customer routing. Traditional peer-to-peer VPNs are implemented with packet filters or shared provider's edge or PE routers, or with dedicated pre-customer PE routers. So in addition to high maintenance cost for the packet filter approach or equipment costs for the dedicated per customer PE router approach, both methods require the customer to accept the provider assigned address space or to use public IP addresses in the private customer network. So modern MPLS VPNs provide all the benefits of peer-to-peer VPNs and alleviate most of the peer-to-peer VPN drawbacks, such as the need for common customer addresses. So overlapping addresses, which are usually the result of companies using private addressing, are one of the major obstacles to successful peer-to-peer VPN implementations. So MPLS VPNs solve this problem by giving each VPN its own routing and forwarding table in the router, thus effectively creating a virtual routers for each of the customers. Now, what are the benefits of the virtual private networks or VPNs? Let's talk about flexibility. So VPNs offer flexibility because site-to-site and remote access connections can be set up quickly and over the existing infrastructure to extend the network to remote users. So extranet connectivity for business partner is also a possibility. Okay? And a variety of security policies can be provisioned in a VPN, thereby enabling flexible interior connection of different security domains. So you can set up and restructure networks quickly. Next would be the network cost. So lower network communication cost. So lower cost is a primary reason for migrating from the traditional connectivity option to a VPN connection. So reduced dial-up and dedicated bandwidth infrastructure and service provider costs make VPNs attractive. So customers can reuse existing links and take advantage of the statistical packet multiplexing features. Next would be scalability. So VPNs allow an organization to leverage and extend the classic one to more remote users and external users. VPNs offer scalability over large areas because IP transport is universally available. This arrangement reduces the number of physical connections and simplifies the underlying structure of a customer's want. One backup technologies. So let's take the one backup strategies here. So this section describes various backup options for providing alternative paths for remote access. So one links are relatively unavailable, okay, or unreliable compared to LAN links, and often are much lower than the LANs to which they connect. So this combination of uncertain reliability, lack of speed, and high importance makes one links good candidates for redundancy to achieve high availability. So branch offices should experience minimum downtime in case of primary link failure. A backup connection can be established either via dial-up or by using permanent connections. So the main one backup options are as follows. So you've got the dial-up backup routing. You've got the permanent secondary wireless or the permanent secondary one link, okay? The shadow PVC and the IPsec tunnel across the internet. So for every connectivity of the remote offices to your headquarters, so there should be a corresponding backup. Let's have our first example here. Permanent secondary one link. So deploying an additional permanent one link between each remote office and the central office makes the network more fault tolerant. So this solution offers the following two advantages. So first, you've got to provide a backup link. The backup link is used if a primary link that connects any remote office with the central office fails. Routers automatically route around failed one by using the floating static routes and routing protocols such as EIGRP and OSPF. If one of the link fails, the router recalculates and sends all traffic through another link, allowing applications to proceed if a one link fails, so thereby improving application availability. So also, you've got the increased bandwidth. So both the primary and the secondary links can be used simultaneously because they are permanent. So the routing protocol automatically performs load balancing between two parallel links with equal costs or an equal cost if EIGRP is used. The resulting increased bandwidth decreases the response time. So in the figure, the connections between the enterprise edge and the remote sites here use a permanent primary and secondary one links for redundancy. A routing protocol such as EIGRP that supports load balancing over an equal path on either a per packet or per destination basis is used to increase the utilization of the backup link. Next example is the shadow PVC. With a shadow PVCs, as long as the maximum load on the shadow PVC does not exceed a certain rate, such as 1/4 of the primary speed, while the primary PVC is available, the service providers provides a secondary PVC without any additional charge. So if traffic limit on the shadow PVC is exceeded while the primary PVC is up, the service provider charges for the excess load on the shadow PVC. Now, this figure here illustrates a redundant connections between the remote sites and the enterprise edge using a shadow PVC offered by the service provider. So because of the potential for additional costs, the routers must avoid sending any unnecessary data, except, for example, routing traffic, over a shadow PVC. The Internet as a WAN backup technology. So this section describes the Internet as an alternative option for a failed WAN connection. This type of connection is considered best effort and does not guarantee any bandwidth. So common methods for connecting non-contiguous private networks over a public IP network includes the following. So you've got the use of the IP routing without constraints. You have the grid tunnels and the IPsec tunnels. So if you want to learn more about VPNs, you can go ahead and check the supplementary videos on VPNs. Layer 3 tunneling. Layer 3 tunneling uses a layer 3 protocol to transport over additional or another layer 3 network. So typically, layer 3 tunneling is used either to connect two non-contiguous parts of a non-IP network over an IP network or to connect two IP networks over a backbone IP network, possibly hiding the IP addressing details of the two networks from the backbone IP network. So following are the two layer 3 tunneling methods for connecting non-contiguous private networks over a public IP network. So first is with the use of GRI. So GRI is a protocol developed by Cisco that encapsulates a wide variety of packet types inside IP tunnels. So GRI is designed for generic tunneling of protocols. In the Cisco iOS, GRI tunnels IP over IP, which can be useful when building a small-scale IP VPN network that does not require substantial security. So it is simple and flexible for basic IP VPNs. Packet payload is not encrypted. This is a non-secure VPN protocol, and provisioning of tunnels is not very scalable. So the next option is the use of IPsec. IPsec is both a tunnel encapsulation protocol and a security protocol. So IPsec provides security for transmission of sensitive information over unprotected networks, such as the Internet, by encrypting the tunnel's data. So IPsec acts as the network layer in tunneling or transport mode and protects and authenticates IP packets between participating IPsec devices. So again, when we say IPsec, packet payload can be encrypted, IPsec receiver can authenticate source of packets, and it uses the IKE and PKI. Enterprise WAN architecture considerations. So support for network growth. Enterprises that anticipate significant growth should choose a technology that allows the network to grow with their business. So WAN technologies with high support for network growth make it possible to add new branches or remote offices with minimal configurations at existing sites, thus minimizing the cost and IT staff requirements for such charges. So the next one would be appropriate availability. So businesses heavily affected by even the smallest disruption in network communications should consider high availability and important characteristics when choosing a connectivity technology. Highly available technologies provide inherent redundancy where no single point of failure exists in the network. Next would be operational expenses. Some WAN technologies result in a higher cost than others. A private line technology such as the old frame relay or ATM, for example, typically results in a higher carrier fees than a technology such as IPsec IPVPN, which takes advantage of the public internet to help reduce costs. So the next one would be operational complexity. So the metropolitan area network and the wide area network technologies have varying levels of inherent technical complexity. So the level of technical expertise required within the enterprise also varies. So in most cases, businesses can upgrade their MAN or WAN and take advantage of the expertise of the existing IT staff, requiring minimal training. So next would be voice and video support. So MAN and WAN technologies support the quality of service, which helps enable advanced applications such as voice and video over the network. Next would be effort and cost to implement, to migrate from private connectivity. So when an enterprise is migrating from private connectivity to another technology, it is important to evaluate the short and long-term costs and benefits for this migration. Last would be the network segmentation support. Network segmentation means supporting a single network that is logically segmented. One advantage of network segmentation is that it reduces the expenditures associated with equipment and maintenance, network administration, and network carrier charges as compared to separate physical networks. Cisco Enterprise MAN and WAN architecture. So what are the technologies here? The Cisco Enterprise MAN and WAN architecture employs a number of MAN and WAN technologies engineered and optimized to interoperate as a contiguous system, providing the integrated QoS, network security, reliability, and manageability required to support a variety of advanced business applications and services. So these technologies include a number of secure alternatives to traditional private WAN connectivity and help increase network scalability and reduce monthly carrier fees. Now for the comparison, the Cisco Enterprise MAN and WAN architecture includes the following technologies as summarized in this table here. So you've got the private WAN, the ISP service, site-to-site, and remote access IPsec VPN. You've got the SP MPLS and IPVPN, and you've got the self-deployed MPLS. Now for the private WAN, private connectivity takes advantage of the existing WAN technologies or other connections to provide an additional level of security when connecting sites. Strong encryption like DES, 3DES, AES, and others can be added. That ensures strong security. Next would be ISP service. So site-to-site and remote access IPsec VPN. These technologies take advantage of the ubiquity of public and private networks. The use of strong encryption standards like DES, 3DES, AES, and others makes this one option more secure than traditional private connectivity and makes it compliant with many new information security regulations imposed on government and industry groups such as healthcare and finance. So next would be the SP MPLS and IPVPN. A network-based IPVPN is similar in many ways to private connectivity, but with added flexibility, scalability, and reach. Now for the self-deployed MPLS, this is a network segmentation technique that allows enterprises to logically segment the network. Self-deployed MPLS is typically reserved for very large enterprises or an SP willing to make a significant investment in network equipment and training, and for those who have an IT staff that is comfortable with a high degree of technical complexity. Enterprise can use a combination of these technologies to support their remote connectivity requirements. So this figure here shows an example implementation of a combination of three technologies in a healthcare environment. Selecting enterprise edge components. So after identifying the remote connectivity requirements and architecture, you are ready to select the individual WAN components. So of course, that includes hardware and software. Now, hardware selection. When selecting hardware, use the vendor documentation to evaluate the WAN hardware components. The selection process typically considers the function and features of the particular devices, including their port densities, packet throughput, expandability capabilities, and readiness to provide redundant connections. Now, for the software selection, the next step is to select the appropriate software features. Now, when using Cisco equipment, the software is the Cisco iOS. Now, when using a non-Cisco devices, so you have the same considerations. Now, as illustrated in the figure here, the Cisco iOS software has been optimized for different markets, network roles, and platforms, just like any other brands. So Cisco iOS software meets the requirements of various markets. This includes the enterprise, service provider, and commercial, and places in the network, access, core, and distribution, and the edge. Now let us summarize designing the enterprise WAN. Traditional WAN technologies include list lines, circuit-switched PSTN, and packet-switched networks. Remote access networks connect teleworkers and traveling employees. A VPN provides connectivity over a shared infrastructure with the same policies and performance as a private network. WAN backup strategies are needed to provide high availability between remote sites. The Cisco Enterprise WAN and MAN architecture provides integrated QoS, network security, reliability, and manageability. Enterprise WAN design includes selecting the appropriate components, including hardware and software.